Hi students, this section is working with scientific notation. So what is scientific notation? It is where you simplify out a value. And I have some examples here of what scientific notation looks like. So if we're working with the number 64,300, how would you write that in scientific notation? It would be 6.43 times 10 to the fourth. How did we get that? Well, look at the bullet point below here. It says, when writing in scientific notation, the decimal is always placed between the first and the second values of the number. So when we have 64,300, with that saying, we need to put the decimal between the 6 and the 4. And then what we have to do is think, from that decimal, how many places do we jump to get to the end of the number, which is right here at the end of 0? So we go 1, 2, 3, 4, and that's how we got times 10 to the fourth, because we're working with bases of 10, and it takes us 4 jumps to get from that decimal point in between the 6 and the 4 to the end of that number right there. So let's look at another example. We have 3,072,000. And so how do we get our scientific notation? We put the decimal between the 3 and the 0. How many jumps does it take to get from that point to the end of the number? We go 1, 2, 3, 4, 5, 6. So that's how we got times 10 to the 6th power. Now, the last example here, it's a little bit different because notice we have with our base 10 a -2 exponent. Well, it's because it's in a decimal form. So again, we put the decimal between the 4 and the 2 right there. And then what we do is we jump, excuse me, going to the left, 1, 2. And there's that decimal place where it is located within the number. So we move 10 or 2 places to the left, and that's how we got an exponent of -2. Let's look at these examples here. It says, write in decimal form these situations. So here we have it in scientific notation, and they want us to put it back into like standard form. So we have 3.128 times 10 to the third. So if I write 3.128, that's saying we're moving the decimal. When it says 10 to the third, move that decimal 3 places to the right, 1, 2, 3. So what my number here is 3,128, and that's my answer. For B, we have 6.4 times 10 to the fourth, so I'll write 6.4. This decimal, we're going to move 4 places to the right, 1, 2, 3, 4. I fill in those empty spaces with zeros. So this value here is 64,000. Answer. The next one here, we have 6.12. Here we have a negative exponent, -5. So we have 6.12. Here we're moving to the left now, 5 places, not to the right. When we move to the right when the exponent's positive, we move to the left when the exponent's negative. So we go 1, 2, 3, 4, 5. Again, we fill in those empty spots with zeros. So we have 0.0000612. Answer. So that's how we go about doing that. Our second set of examples here is they are giving you the standard form value, and they want you to write it in the scientific notation, what we've been talking about. So here we have 52,314. So remember that decimal goes, we need to place that decimal between the first and the second. So this is going to be 5.2. We do have to write the rest of the numbers here, 314. But if I put the decimal between the 5 and the 2, how do I know my exponent? So with my times 10, my base 10. So what's my exponent? Well, we go 1, 2, 3, 4. So that's going to be times 10 to the 4th power. And this would be my answer in scientific notation. Let's look at B here. We have 3.2. Then 3.2. That's just my answer. And so with this, it's not giving me a whole number. If this was like 32, we would have 3.2 times 10 to the first. But since my number here is 3.2, this is just going to be 3.2 times 10 to the 0 power, because we're not moving that decimal around anywhere. It's just that 3.2. So this is going to be my final answer right there. For C, here we have a decimal value. So we need to think of the decimal between that 4 and the 7 right here, those first two numbers. So we have 4.71 times 10. How many places do we move to get to that decimal? We go 1, 2. So 10 to the negative second, and that would be my answer. For D, we have 602 million. So I'd place the decimal between that 6 and the 0, so it's 6.02 times 10. How many jumps do we get to the end of the number? We go 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th, and that would be my answer in scientific notation. So the last two slides we talked about writing in scientific notation, or taking a scientific notation and writing it in standard form. So now in the next slide we're going to dig a little deeper into this, and we're going to work with multiplying and dividing scientific notation situations. So if we look at A here, it says evaluate the expression and write the results in scientific notation. So we're writing our final answer in the scientific notation form. Here we have 2.5 times 10 to the 4th times 5.8 times 10 to the 2nd power. What I would do is I would group this, and I would multiply 2.5 times 5.8 together. And then since we have like bases here of 10 to the 4th and 10 to the 2nd, multiply that. So we have 10 to the 4th times 10 squared. Well, this 10 to the 4th and 10 squared, we've been working with that. And when you have like bases, when you're multiplying, remember you add those exponents. So technically this is going to be 10 to the 4 plus 2 is 6 power. So we've taken care of this set here, but we need to multiply 2.5 times 5.8. When you multiply that out, you're going to get 14.5, and that's times 10 to the 6th. Now we do have to take this one step further because they want it written in scientific notation. Remember on that first slide I mentioned, when you're writing numbers in scientific notation, the decimal needs to be between the first and the second when it's working with a non-decimal number, I should say. So what we have here, it's going to equal 1.45. Since we move this decimal 1 to the left, what that means is we now, with this 10 to the 6th, we need to add 1 value to that exponent because the way we place that decimal. So my final answer is going to be 1.45 times 10 to the 7th power, and that's my answer. We will keep practicing some more of this in class, but I moved this decimal to the left because with scientific notation, that's how it needs to be written. And since we moved the decimal to the left, that means we needed to add 1 more to my exponent to make that 7. Looking at B here, we have, now we're dividing. We have 1.82 times 10 to the negative 1. Divided by 1.4 times 10 to the negative 3. I would rewrite this out in this form of 1.82 times 10 to the negative 1 divided by 1.4 times 10 to the negative 3rd power. When I write it in this form, it's going to be easier to work with because if I draw a line here, I'm going to separate and divide this 1.82 divided by 1.4. But then we have this 10 to the negative 1 and 10 to the negative 3. Since we have like bases here, we can subtract my exponent. So we can think of this as 10 to the negative 1 minus a negative 3, which that becomes 10. Negative and negative become positive, so that's going to be negative 1 plus 2, which gives me, negative 1 plus 3, which gives me 2. So that's 10 to the 2nd power. And then I just divide that 1.82 and 1.4, and I get an answer of 1.3. And since when I divided this, my decimal was between the 1st and the 2nd, I can leave this answer the way it is. I don't need to shift or move that decimal and then add or get rid of a number with the exponent. We only had to do that to the first one. So this would be my final answer for B. So we'll practice this some more in class, and I hope you wrote all the details down for these notes.